Since its incorporation, Evimar has been designing and manufacturing electronic devices for security systems, network infrastructure, and automation. The main product line consists of surge protection systems, supplemented with solutions that simplify installations and reduce the number of accessories used therein. In addition, our offer includes products designed to integrate systems of various manufacturers, devices for wireless transmission, telemetry, power supply, and control. First, let's address the general purpose of surge protection and the phenomena that support the need for their use in modern installations. Security systems such as CCTV, alarm systems, or access control systems require uninterrupted operation. It should not depend on weather conditions, interference, power line interruptions, or other external factors. Lightning, which can result in damage to electronic equipment, may cause an interruption of service to a part or the entire system. Surge protection reduces the risk of damage to the equipment that it protects, but also greatly protects other electronic installations in the vicinity. The failure rate of modern electronics is influenced by two main factors. The first is the increasing frequency and intensity of weather anomalies. Since the 1980s, climate change has noticeably accelerated, increasing the frequency of lightning around the world. Lightning starts as early as spring and ends in late fall, and can also occur in winter. The lightning produces an electric arc, commonly referred to as thunderbolt, which has a voltage of millions of volts and a current of thousands of amperes. The electric field causes a series of spark jumps between metal structures and wires. The lightning is also accompanied by a strong electromagnetic pulse, covering a large area around the impact site. It penetrates traditional building walls and induces high voltages in wires that damage electronic devices. The primary protective element of buildings is the lightning protection system, but it cannot effectively protect electronic equipment from damage. Studies show that only half of the lightning charge is effectively dissipated to the ground, while the rest is dissipated in the environment and any materials capable of conducting electricity. The second factor for low surge resistance is the increasing miniaturization. It undoubtedly brings a huge number of benefits, such as reducing the size of equipment, saving energy, increasing computing power, as well as reduction in the consumption of hard-to-reach or harmful minerals. The downside of miniaturization is, unfortunately, low lightning resistance. This has to do with the reduced size of the components and the reduced supply voltage. Each electronic component is designed with maximum permissible parameters in mind, which include voltage and current. An increased voltage caused by lightning results in an increased current flowing through the electronic component. The excess power thus generated must be dissipated to the environment as heat. The effectiveness of heat dissipation depends on the thermal contact area of the component with air and other components, such as a heatsink or printed circuit board. Large-scale miniaturization components have very little surface area capable of dissipating excess heat, so they are destroyed very quickly by overheating. In the figure, we have the actual differences between the resistor sizes produced starting from the 1980s to those produced today. On this basis, we can grasp the scale of miniaturization and ability of such devices to dissipate heat into the environment. The scale of miniaturization of semiconductor components is several times greater than that of the resistors shown, so they can be damaged even more easily. Let us now focus on the financial and social aspects that speak in favor of the use of surge arresters. Security systems are designed for continuous operation to protect health, life, and property. A malfunction in even one component of the system significantly affects the effectiveness of hazard warning. A device damaged by lightning may fail to detect burglary, property vandalism, or fail to document theft. The costs incurred in this way can be many times higher than the cost of replacing components damaged by lack of surge protection. Products damaged by random events are not subject to warranty repair and often open a dispute between the investor and the repair service. High miniaturization means that damage to modern electronics is mostly not directly visible. Modern communication infrastructure is based on low-voltage signals, which makes it particularly vulnerable to surges induced in wires during lightning. Security system components installed outdoors, such as cameras or motion detectors, can also compromise other installations indoors. The widespread availability of surge protection devices should not be ignored by designers and installers of security systems. When ordering the installation, investors trust in the professionalism of the system installer and their knowledge of potential threats. If the installation company intentionally omits surge protection solutions, it deliberately exposes the investor to the risk of losses and thus loss of trust. A contractor that proposes protection systems demonstrates a high level of professionalism and protects themselves against potential claims. Note that the installation can also be damaged by vandalism from high-voltage generators, such as stun guns. The level of overvoltage hazard depends on where the electronic device is installed. The low price of system components may encourage the omission of arresters. However, keep in mind that spark jumps penetrating from an external unprotected CCTV camera can transmit a destructive electrical charge to the LAN, antenna, or telephone system and cause a lot of damage. Thank you for looking at our material.